All right, step two, and this is just gonna go over the idea that I just nailed home. Here it is, an inscribed angle, that angle that touches the edge of the circle with its vertex and cuts some sort of chord or arc into it. All right, here we go. I'm going to read the example definition up top. The measure of an inscribed angle is equal to half of its intercepted arc. All right, or you can think of it the other way. The measure of an intercepted arc by an inscribed angle is double that of the inscribed angle itself, and I'm going to show you what I mean. I'm going to create number one for you, and I may not be perfect here, but I'm going to say A, B, and C. I think that's how they have it listed, and I am correct. And they say that this in here is 36 degrees, and they say, okay, well, the measure of that inscribed angle is half of the arc that it's intercepted. All right. So if we want to know what the measure of arc AC is, and that's what number one is asking for, it says, hey, what is the measure of that? And if this is half of that arc, then all we have to do is double that 36, and we have our answer. Okay. So if we double our 36, all you have to do is multiply it by 2. But if you can do it in your head, then we know that it's 72. Right? So there's number one. I want to do number two. Number two actually just gives you a value on the outside, right? Number two says, and it's a little crooked, but I don't want to just erase this and rewrite it. It says that out here it's 62 degrees. Well, this says the measure of an arc that's intercepted by an inscribed angle is double the measure of that angle. Okay, well, if this is double what this is supposed to be, then all we have to do is divide that by 2. And if we divide 62 by 2, then we get 31. You know, what's half of 62? It's 31. So they match up that way. I need you to see that they match up this way. The measure of this angle is twice that. And really the reason that this exists like this is I want you to look at the distance. This is a diameter, right? I want you to look at the distance. We said that an inscribed angle touches way out here, right? So that's 31. Looks like a horrible 31. Sorry about that. I want you to look at it. It's double that distance, right? And so if an arc is named by the angle that creates it, let me use a different color. See if that helps you out any. The angle that creates it, if it's, you know, half the distance away, and half that distance, oh, that does look sort of like a 62-degree angle. Okay? These arcs are named by their central angle. Oh, well, that makes sense. This has to be twice as large because it only covers half the distance from the center of the circle out, and this goes all the way across the circle. So that's why that is. That's why that exists like that. That's how we can make these assumptions, or that's how we know that these theorems are correct. It's because that central angle names that arc, but we've gone twice the distance to create a smaller angle to get there, and that's why that inscribed angle, since it's all the way out there at the end, shows us that it's only half the size of that bigger angle that would have actually created it. And so I want you to be able to do 1, 2, and 3 that way. All right.